All right, 10:02. We'll get rolling here today. Lecture 5. It's cold in here, huh? I guess now, I don't know if you saw in the Wall Street Journal that Hunter is the number 2 best value college in the country. Right? They have an interesting definition of value there. It has to do with how long it takes you to pay back your tuition once you've graduated and gotten a job. But we know now that one reason why tuition is low at Hunter is because they don't spend much money on heat in these classrooms. Right? Actually, maybe it's like too much air conditioning, or I don't know. Anyways, okay, lecture 5. Today we're going to talk a little bit about consumer and producer surplus. And really this continues a theme that we started last class, which was thinking a little bit about the geometry, right, of our diagrams, our supply and demand diagrams. So before I jump into that, I'm going to just kind of handle the usual bookkeeping stuff. So you see here I have an attendance thing rolling, and I was, it's the first time, so I'm sure there's going to be glitches and all that stuff. So, if you can log into Top Hat and do it, or however it is you prefer to do this. If it doesn't work, if something goes crazy, just send me an email and say, it's the first time, so you can send me an email and say, I was there and, my phone freaked out or something. But we'll give it a try. It looks like 95. Okay, we're getting there, right? What do we have? Almost 100. 331. Seems like a lot. That seems like a high number of people here. So I'm guessing that we're getting close to, if we get up around 200, I think that's about the regular roster size. So thinking out loud there. Okay. So we're getting into chapters 6 and 7, and I was kind of caught up doing other things this morning, so I haven't posted that yet, but suffice it to say later today I'm going to put up another couple reading chapters, and I'm going to add another homework. I'm kind of pushing these things ahead a little bit because I'm trying to get everything up and ready for the exam, right, which is I'll talk about in a second. So my office hours are roughly 10 to 12, Tuesday, Wednesday. I have some good news. We have a TA, Ishi Del Rosario, and Ishi will have some office hours as well, right? So I've sort of said maybe the best thing to do is have these office hours at some point in the afternoon and maybe make them available via Zoom as well. So we'll iron that out in the next couple of days, and then I'll give you all the contact information there, right? And so here's my guess about what will be on the exam. It's looking like chapters 1 through 8, maybe the first 5 homeworks as well. And also, I'll remind you, I have to have my verification of attendance, right, that you've been here at least once in this class. I have to do that tomorrow, so it's kind of your last chance to send me an email if you haven't shown up on Top Hat or anything like that yet. And so exam, let me jump into this stuff. If you're just coming in, you can see the Top Hat attendance exercise there. So here's my little calendar. We have class on the, 16th is today, so we have the 19th, the 23rd, right? Boy, that's a week from today. It's coming up very suddenly, right? The 23rd, I will distribute a practice exam and all of that stuff, and we will go over that on the 26th, and then we'll have our first exam on the 30th. I know it's happening kind of suddenly, but we're better off just sort of, I feel like it's good to get it into the semester and get that exam under our belts, because I know that you typically will have a slew of exams a week or two after that. So I'm trying to be first with this, and you'll see how it all works, right? We still have 2 weeks to figure it out. Just so you know, though, there is an in-class component and an online component. The online component will go through Top Hat. So I'm sure most of you, it looks like, we have more than enough people signed up for Top Hat. Where are we now? We're at 41%. It's also good to sort of figure out a place where you can use the software and it's stable and you're not losing your, internet access, stuff like that. So there's also that, as you use Top Hat, just experiment with a good system for you that you can count on, because it's very hard, as we're doing this exam, and there's this online component. If you're taking it at 10 at night and something goes wrong, and it's hard to get in touch with me to fix anything at that point. So preemptively, we can try to figure out all of these things. And of course, you can also see that, what is that 29 doing there? There's a typo in the middle of, trying to confuse everybody here. The great thing about Google Slides is you can just remove any typo there. And you see here Wednesday, the homework, all of the homework, what is this? That's the 2nd of October, will be due then. So you have a couple of days after the exam to continue to work on the 5 or so problem sets that we'll probably have there. One other thing is people have had questions about homework. I have a collection of those, and I think I might dig into those next time a little bit. The other thing is there's some grading glitches. There's like one question, I think on homework 1 or 2, where you're supposed to key in some information. And it's like one of these things where I can sort of set it up to record that you've done it and give you credit for it. But I do have to go in and grade it by hand. So people have noticed, people have said, well, it keeps marking my thing as wrong. It's because I haven't graded it yet. I'll take care of it after October 2nd. Right? And indeed, that'll be a big period of time where we can sort of make sure all of the I's are dotted and T's are crossed with all of this homework stuff and grades and all of that. All right, well, I think I'm going to dive into the material today. What am I? There we go. So last time we talked a little bit about comparative statics, as I called it, and changes, right? Market changes, I should say. Changes in demand and or supply. So typically what we do is we sort of think about, if we're trying to parse an effect, something that might happen in one of our markets, what we do is we start out by saying, okay, well, suppose our market started at this supply and demand equilibrium, right? Now something happens, right? We shift a curve around, one curve or both curves around, and then we look at the new equilibrium and we compare the new one to the old one, right? And we say, okay, well now price is higher or price is lower. And so I have a couple of interesting examples here. Hopefully they're interesting, or just examples to practice with. So let me briefly do this. Let's see. Frosts in Florida and oranges, apples and pears, live concerts when music is easier to download and share. Okay. So a mental note. I'm just trying to, because I have to go to the overhead here. So let's think about this market for oranges when there are heavy frosts in Florida. So what I'll do is I'll just draw a standard demand and supply curve here. Quantity price. Let me see what that looks okay, right? All right. Here's our equilibrium. Initial price and quantity. Right. We can call this whatever we want. I'll call it P with a little E subscript there. Okay, and so if there's heavy frosts, what should happen in this market? Well, if you think about it this way, this might make it more difficult for suppliers of oranges to produce them and bring them to market. Right? And so we might expect that this changes the supply, right? A shock to supply, if you want to think about it that way. So the idea that supply gets harder for businesses or farms, as the case may be, orange growers, usually you reflect that by a shift back in the supply curve, right? And we can do out our comparative statics here. And we can say, all right, well, let's see, the original equilibrium was here. Now we've had this shock. The supply curve shifts back, and we can see quantity is down and price is up, right? So there's a very simple prediction about how the market might respond to this change. My next one was the market for apples when the price of pears goes down. Was that what it was? Down? Okay, so for some reason the price of pears has gone way down, right? So it's become a lot easier to supply pears. Maybe some new strain of seed has been discovered or something like that. So the pear market has has a lot more pears. The price goes down, and now we're talking about a related market, the market for apples. So I would typically think of apples as a substitute, or pears as a substitute for apples. So we would say, well, what happens when the price of a substitute goes down? Well, then people won't become more willing to buy that substitute product vis-a-vis the product we're talking about, apples. So we might expect that this would shift back the demand for apples. So we should really be a bit more careful with kind of filling out the diagram here. We start off with the price and quantity here, right? And we shift back this demand like that. And you can see what we would expect to have happen here in our market for apples is that, well, the quantity exchanged in the market would fall, and also the market price would fall, right? Very simple comparative statics, right? Just comparing two equilibria, right? As we shift things around.
Is this quantity is how much there is on the market, or how much people buy?
Okay, so you would say that this is, well, I guess they're sort of the same thing in equilibrium, right? That's a good point, yeah. So is it how much is in the market or how much is actually bought? Well, the beauty of an equilibrium is that the two are the same, right? Quantity demanded and quantity supplied are the same. So I kind of threw in the last one here, which is about concerts and music and being able to download music and share it that way. It's because, I don't know if there's any clean answers here, but it'll kind of dovetail with some things I'll talk about a little bit later, which has to do with unintended consequences. And it's kind of an interesting situation where I try not to have you shift everything at once, but we might sort of think about how demand and supply are impacted by this thing. So, and this is a very interesting one because you have to have sort of an argument about the essence of the product here. So, I kind of like these questions about music because being, sort of born in the 70s, I grew up in the 80s, and, of course, all of this stuff. I'm of this generation where I've had to rebuy my music collection like 2 or 3 times at least, right? Because we started out in the 80s, or in the 70s, everything was records, right? Both 45s and LPs. And then, of course, the cassette tape and the 8-track tape became a big deal in the 80s. And then in the 90s, we had CDs, and now we don't really have any of those, right? It's kind of interesting. My youngest child doesn't even, a cassette tape, she's like, what's that? But anyways, there's been some other changes in the music industry, and one of the things that happened, this was, in the early 2000s, where they really hadn't quite figured out how to, charge people for music. I guess it's still kind of hard, right? And everybody was sort of file sharing and all that stuff. The question became, well, what does this do? How does this impact the demand for live music? Or you can think about it as that's my question here, right? How might we expect this change in technology in, I guess, the price of or the provision of a related product, I'll say, right, free music, how would we expect that to interact with live music? Now, you can think about this in one of two ways. Either music that you consume, like on your own, is a complement or a substitute for live music, right? So you can listen to something instead of going to a concert, or you can listen to something and it makes you want to go to the concert, right? That's a complementary story, right? And I think maybe maybe we could say that's the right one. I don't know. How many people think complements? Just a little show of hands here. So you listen to some music, you want to go see the concert. How about substitutes? Okay, well we have some of both there. We can sort of think about what would happen in either one of these cases. If music, I guess recorded music is complementary and it becomes easier to access, well, you would expect that would shift out the demand for live concerts, right? So you might expect to see something like this, right, in that case. So now we would expect that the price of concerts would go up and there would be more of them. kind of seems like that's what's happened, right? There's a lot that's changed, but it seems like there's a lot more, the concerts are bigger and they're, more expensive, and there seems like there's more of them every summer. But that could just be, maybe it's just me, living in New York City versus when I was a kid and I didn't live near the city. So who knows? But that's one idea about how this might work. Of course, if we think about the substitute case, we might think about it as kind of working the other way, right? Where we might say, well, okay, if it's a substitute, then people can get the music that they want, just download it and listen to it. Well, then that should reduce the demand for concerts. So we could see that might suggest a fall in price and demand, right? Price and quantity demanded and supplied. So you can get different things from these examples, and it's worthwhile to just kind of think these things through and maybe the broader trends. I find it interesting, like the way the industry has changed, and back in the 70s and 80s, there were a whole bunch of these bands that were really just studio bands, like Steely Dan and the Human League, bands like that. If maybe you don't even know who those are. But now things are such that if you really want to make money as a performer, you kind of have to go out there and tour, right? And you can make a lot of money. So maybe this gives a little bit more credence to the complementary story, right? This idea that if your music can get out and get to everyone, well, then you can tour, and make money that way. Or maybe you have to make money that way. So that's an interesting possibility. And even though we're pushing, I guess we're pushing our model a little bit in terms of, you can only get so far with supply and demand. We'll need some additional tools to think about more complex cases. But it's still fun to do, right? And it's still good practice to just kind of work these things through. So as a last example here, I have our demand for water, where I've used, my usual example where there's some sort of shock to the quality of tap water, right? The quality of tap water, and you might expect that would, that's a substitute product for bottled water, so you might expect that if people became less willing to consume tap water, they would become more willing to consume bottled water, and that would have some effect like this, right? Once again, just there it is on a slide, an example where we have an increase in demand. Right. So it's kind of fun to think about these things also, and this will give you a little bit of practice with shifting both curves. And these examples aren't perfect, but at least they're somewhat thought-provoking. And I really like the second one, the price of flowers here. But one of the interesting things that happens around certain times of year is we have these products that we like to consume. Of course, a great example is turkey and Thanksgiving, right? And it turns out that, does anybody know what happens to the price of turkey around Thanksgiving? It actually goes down, right? It's a little bit cheaper to buy a turkey around Thanksgiving. And it's also interesting, just how little turkey, whole turkeys people buy during the rest of the year, right? I actually cannot remember ever buying a turkey at any time other than Thanksgiving, right? Myself, but you might think about this as strange because we have this, massive increase in demand for turkeys right around Thanksgiving, but at the same time the price is a little bit lower. Well, we can make sense of this. Here's a nice article if you want to take a look here. Right? Whole turkeys are suddenly discounted by supermarkets and grocery stores. There's a little bit more to this story than I'm going to tell you right here, but we can kind of just think about it using supply and demand and see how we could get such an effect, right? A rise in demand and also get a price going down. But we might have to, push our diagram a little bit further to do this. So here we have demand, here we have supply, right? And we know that demand will go way up for turkeys. I should really finish labeling all my diagrams here. We know that demand will go way up around Thanksgiving, but it's also the case that there's, that's not the only change. There's a whole bunch of, there's a big increase in supply to meet this demand as well, right? So we might say that there's a simultaneous shift in supply, right, around this holiday. And so you can kind of see what we get here. Well, in the way I've drawn the diagram, we started off with the price and quantity here, right? And when we shift both of these curves, we wind up with this quantity that's way up here, right? A big increase in quantity. And, I didn't draw it perfectly, but not much change in price, right? And so that might be how we get the desired effect here. Now there is a little strategic element here that we are not yet equipped to talk about that'll go beyond our simple supply and demand diagram here. And this has to do with pricing strategies. And in fact, I had a student asking me last time about pricing strategies. We're going to get there in a couple weeks, how we can think about things like that. But one interesting thing about turkeys that article suggests is that it is a loss leader. A turkey is a loss leader. Now, what is that? And how does that work? Well, details will come in subsequent classes, but the idea there is that oftentimes businesses sell things at a price, at a loss price, right? And it gets you in the door, and then they make money off of all the other stuff that you buy there. So, for example, the supermarket sells you a cheap turkey, and then sells you all the other stuff: the stuffing, the gravy, the cranberry sauce, all that stuff that goes along there. Now, it's interesting that we have a similar effect here, and this is I really kind of like this one, why flowers get so expensive on Valentine's Day. Now, flowers are a little bit different than turkeys. The flower industry is actually quite fascinating. There's a whole bunch of things that you might or might not know about it. One of which is that there are massive auctions going on virtually every day over flowers, right? Buying and selling of flowers. And hopefully we'll have a chance to talk about that later in the semester as well. But flowers are a little bit different. You kind of buy them, roses in particular, you buy them throughout the whole year. And it's kind of interesting here. And I really like the way this article, there's one point in it, I should have dug it out ahead of time. It's all about flowers. Okay, so, and here it's kind of interesting. They talk about costs and all of that stuff, but I would prefer to kind of do this as simply as possible in our diagram. And hopefully I can even foreshadow something about what we'll say later in class here. So in Thanksgiving we have a similar problem, Valentine's Day we have a similar situation going on, right? Where we have demand and supply like this. Now, as I said, flowers are kind of being supplied all year round anyway, so it's a little bit different than turkeys. There isn't this enormous spike in supply at one time of year. But we could do the same thing as before. Around Valentine's Day, we get a shift out in demand for flowers. So again, I should label everything here. And at the same time, maybe we get a mild change in supply, right? And we can draw those. That's not what I wanted to do. We can draw those so that here's my price and quantity at the initial equilibrium. And then at our new equilibrium, after these things have changed, right, we have this quantity and this price here. So once again, we can see that we get now a higher price and a much higher quantity traded as a result of these changes. Now, the article did say something about rising costs, right, or being more costly to supply flowers at Valentine's Day. Now, what I'm hopefully going to show you today is that the supply function here itself, the supply curve, encodes information on costs. And so whenever we move up a supply curve, the implication is that it is getting more costly to provide something, right? Indeed, this is the fundamental reason why supply slopes upward. So that was mentioned in the article. Maybe not in exactly the way an economist might say it, but it was a point of interest nonetheless. Okay. So, all right, now if we circle back to what we did last time, we can talk a little bit about that particular idea in more detail. So, last time we talked about this example of the market for illicit drugs, and we used, I guess you could say, used some of the geometry of the graph, the supply and demand diagram, to say a little bit more about the problem, right? In particular, we observed that there was this rectangle, right, that lie below market equilibrium price and quantity, and that rectangle sort of showed us geometrically the total expenditures on drugs, and we then connected that to something, or we said something else about the market based on how large that rectangle was. And so the other aspect of this that was important was the steepness of the curves. Today we're not going to talk too much about that, but once we get the technical stuff, the technical details in place, maybe we'll have more to say about that next time. But it kind of worked like this, right? We talked about these supply-oriented policies where you shift back, if we crack down on drugs or crack down on sellers of drugs, the idea was that would shift back the supply. And here I have kind of a gray shaded rectangle and a blue shaded rectangle showing how this sort of policy might be expected to change this total expenditure rectangle. I'm relying a little bit on you remembering what we did last time to fill in some of the details here. Okay, now the way I've drawn this, it's hard to tell which is what exactly is happening, right? It's the rectangle is getting taller, but it's also getting narrower, and it's hard to say how its total area has changed. Well, if we drew the curve really flat, as we saw last time, we can then say, well, cracking down on supply, right, making it harder to supply illicit drugs should make the rectangle smaller, right? This would tend to vindicate such a policy, right? A war on drugs style policy, if you want to think about it that way. Well, we could also say that, the legalization policy seems like the right way to go if the demand curve is relatively steep, right? And this way, shifting out the supply, right, making it easier to get drugs in this particular case, or making it easier to supply them, would tend to take all the money out of it, right? It would and that would in turn result in lower expenditures. So we had this idea that when demand is sensitive to price, right? Remember, price changes a little bit here and quantity changes a lot with this flat demand curve. Well, then the best policy would be some sort of crackdown, right? Demand is steep. Well, here price changes a lot. Quantity doesn't change much at all. The best way to get expenditures lower is to let supply shift out, right? And of course, the punchline here was that, you can now see this. We could now see how this these policies where you try to, distinguish between different types of consumers, those with elastic demand, right, perhaps recreational users, and those with inelastic demand, perhaps those who are addicted. We try to separate them and treat them differently. So, quick review of last time, but really what I'm trying to do is highlight how we leveraged the geometry of our supply and demand graph there, right? Okay, so we're going to think about the geometry of supply and demand, and let me, pursuant to that, there's a couple things I've hinted at as we've gone along here. And this will be the key to kind of understanding all of this. My first arrow point there, the demand function, I don't know why I said function, the demand curve, we've observed, encodes information about actual value. Right? That is to say, it doesn't just tell us how much of a product you'll buy at different prices. Right? It also, in some sense, says something about how much you value the products that you buy. Let me just do this. And I'm hopefully going to explain that as we go along here. Put that back up in case you're coming in late here. By the same token, the supply curve encodes information about cost. Right? It tells us something about the costs that suppliers have for supplying whatever product it is we're talking about. And I've hinted at this as we've sort of gone through what we've been saying, or gone through our exposition of demand and supply. And today I hope to make it a lot more precise. So, first we're going to define these new terms, right, which I have here, marginal benefit and marginal cost. So what is a marginal benefit? A marginal benefit, so marginal is the word that economists like to use for additional, right? Additional, but it's nice that we have our own word for this, marginal, because I also want you to sort of associate with it another thing in your mind, and that's given that you have some amount of something already, given some amount you have now, how much do you value an additional unit of that of a particular object, right? So given you're consuming X, right, how much do you value having X plus 1, right? We would define that additional value or that additional benefit as the marginal benefit, right? In the same way, you can think about marginal cost as, if you're already producing a certain number of units, you're a supplier, right, a producer, you're already producing a certain amount of a good, how much would it cost you to produce one more unit, right? Given X, how much does X plus 1 cost, right? So I like this word, having our own word for this, marginal, because I'm hoping you'll associate it with the idea that you're starting at a point and then adding a little bit more and thinking about how your costs or your benefits change. Okay, so I think I have, I'm going to try to do this in scientific, do it quickly here. Nah, it's not so good. That's better. That's okay. Okay. So one thing that you might, if you sort of push this idea of rationality, and I have some numerical examples coming up, and indeed what we're going to do here is kind of like what we've been doing all semester, where we sort of take a very stylized numerical example, right? And we work through its implications, and then we build it into a general principle. And that's kind of where we're going with this. So the way we'll do that is we'll think about how this idea of your marginal benefits, right, from certain units of a product, how that connects to your actual value, and then to some observable consequences, willingness to pay here. So, good example here. Let's suppose I get $6. My first cup of coffee for the day, I get $6 in benefits from consuming it. Right? So if you had some sort of meter attached to my brain, when I drink that cup of coffee, it goes up by $6, right? That's my benefit I get from drinking this coffee. Now, if we think about how that then defines how I should behave as a consumer, well, if the coffee costs $8, I'm not going to buy it, right? If it costs $5, I will. Well, why will I buy it in that second case? Because the satisfaction I'm getting, $6, is greater than the amount I'm paying out, which is $5. So in essence, I pay $5 to get something I value at $6. I get $1 in surplus. So what we're going to do is we're going to sort of, one thing we can do is and I've done this in the past, is use that fact to connect it to actually measuring my benefits, right? And one way you could figure out what this 6 was, at least in principle, is by asking me whether or not I would buy a cup of coffee at a whole range of prices. 1 cup of coffee, right? At this whole range of prices. And then what you could do is you could observe that for all those prices above 6, I don't buy it, and all those prices below, I do, right? And then this becomes kind of an observable consequence here. And so you would say that my marginal benefit from cup 1, given I'm starting at 0, is $6. Now, one other thing we won't say much about today, but we'll use in the future, is that as I buy more cups of coffee, right, we typically imagine that my marginal benefits go down. So think very carefully about what that means. What we're saying is not that I'm made worse off by consuming more coffee. We're just saying that each additional cup gives me less additional utility, right? So for example, I drink that first cup, $6 of utility, I'm excited, I feel better, I've gained some satisfaction. Maybe then I think about getting another cup. I've already had 1 cup, so the second cup is good. I like coffee, but maybe not as good as the first cup. Well, what do we mean by not as good? It would mean I'm not willing to pay as much, or I'm not getting the same marginal benefit out of it, right? So my second cup of coffee, given I've had 1, gives me $4, say, in utility. And so we typically think about marginal benefits as behaving in this way. And maybe you'll see why. I'm kicking myself because I didn't say this in my first class, so I didn't emphasize it anyway. But this is important for the actual demand curve for products as it applies to consumers. We call this assumption, by the way, the law of diminishing marginal utility. This idea that as you consume more of something, you value each additional unit a little bit less, right? And I'm just going to kind of state it here and leave it as that. And this will be about as rigorously as I define it. But in Eco 200 and Eco 300, it's a big deal. Like talking about diminishing marginal utility. Big subject. Okay, so let's go to another example. This is Jacob's consumption of pizza, and I've just made a little chart that sort of follows this law of diminishing marginal utility, or these marginal benefits going down. It looks something like this. So this is what happens to Jacob. That's my oldest son. As he consumes more slices of pizza, what I have here is that his marginal benefit of the first slice that he gets is $8. Well, what does that mean? Well, I guess you could say the observable consequence is that the most he would pay for that slice is $8. Yes? I'm sorry? Max WTP means max willingness to pay. Thank you. Good clarification there. The maximum he would be willing to pay for a piece of pizza. That first slice, well, his marginal benefit's 8, so the most he would pay for it is 8 as well, right? He would never pay more than the benefits. Given he's had one slice, now his marginal benefit goes down, right, it drops to 6 because he's had one slice. He's not as hungry, I guess. Just that simple. He's willing to pay 6 for that, according to my chart, right? Given he's had a second slice, for his third slice he's willing to pay 4, and then we get all the way down to 4 here, and now he's only willing to pay $2 for a slice, given that he's already had 3, right? So you can see this chart here, but notice that this has an observable consequence, right? And that we can say at different prices how much pizza Jacob will actually buy, right? So here I've just basically relabeled some columns, and now we have the slices demanded, and we have the prices here, right? So 1, 2, 3, 4 are the slices demanded. And 8, 6, 4, 2 are the price that he pays. So I'll show you how you can think about this in terms of a graph in a second. But if we put the price at 4, you can imagine him sort of saying, all right, my first slice I value at 8, I'll buy it. My second slice I value at 2. My second slice I value at 6. 6 is still greater than 4, I'll buy that one. The third slice I value at 4. Well, it's kind of a wash, but I guess I'll go ahead and buy it. If maybe the price is a little bit less or something. It's a toss-up at that point. So right up until, maybe I should say it this way, right up until the price is about equal to his marginal benefits, he buys the slice of pizza. Yes?
So is it not cumulative? So like each individual piece loses value as you get more?
Oh, that's interesting. So, right, the question, I know exactly what you're asking. This is not cumulative. It is, I guess I'd say it is cumulative, right? So, I'm going to answer the question this way. I'm going to say, well, let's see here. When we get to slice when he consumes 3 slices, it doesn't mean the first, second, and he gets to this point, it doesn't mean the first, second, and third slice give him 4 units in marginal benefits. He still gets, right, 8 from the first, 6 from the second, and 4 from the third, right? So what does that mean in terms of, I guess you could say, total satisfaction rather than just marginal benefit? That's a great question. Maybe I warped it to suit my own needs here, but that's fine. In fact, let's put it all up here on the put everything up here together. And really the big lesson here is that I'm almost repeating myself by putting this information side by side, right? So here we have the price and the slices. This is the demand schedule. The price and the slices that Jacob buys at each of these prices, the number of slices. Here we have the slices and the marginal benefits that each slice provides, right? So you can kind of see what's going on here is that the fact that Jacob buys slices of pizza right up until his marginal benefit is around the price means that the demand curve mirrors his marginal benefits, right? Well, why do we care about this, or what else is interesting about this? Well, here I've added in that cumulative column, right? Where I can now say how much total value he is getting from consuming pizza if I know his demand curve, right? Which reveals his marginal benefits. So let's see. The first slice gives him 18. So when when he consumes one slice, he gets 8 units or total benefits. Should he go to a second slice? Well, he gets 8 plus 6, the marginal benefits of each slice, right? Added up, gives him a total benefit of 14, right? And so on and so forth down the table. So, if you want to think about what this means, is you can say, well, if we know the demand curve, we know the total satisfaction, right? And maybe just to show you a little bit more how this works mechanically, and this is my kind of, I draw a lot of, when I was a student, I drew a lot of very dumb diagrams, and so I apologize if this seems dumb. By the way, I learned how to use the Google Sheets combined graph here. You can put a line and a bar chart on the same graph here. So what I have in mind here is that the red curve is the demand curve, right? And that these blue bars are the marginal benefits that Jacob derives from eating each slice of pizza, right? So, and really the idea is that, just go from, 8, if you think about the marginal benefits, well, they're the same really as the point along the demand curve. Okay. So I say here, what if I did this for Jacob's entire class? Good question, but let's be even simpler and say, what if I just did this for Jacob and his friend? They might have different valuations, and when I blend those two together, I might get something that looks like this. I did it so it kind of looks like this. So now, what have we learned here? What are we looking at? Think about it this way. When the price of pizza is $10, somebody buys a slice, right? I don't know if it's Jacob or his friend, or put another way, that's the marginal benefit or the maximum someone would pay for the slice, right? Put another, if I lowered the price to 8, well, now we have 2 slices being purchased, right? Well, that looks like 9 actually. Sorry, 10, 9, 2 slices, 8, 3 slices, 7, 4 slices, and so on, right? But notice that what happens is that we now know, even though 4 slices are being purchased at $7, because of the previous points along the demand curve, we also know what the marginal benefits from each of those slices up until this 4th one were, right? And in this case, it's kind of interesting because, this is the market level, I guess, where there's 2 people in the market. We don't know if it's Jacob or his friend who's getting that marginal utility, but we know it's someone. Right? Just because of the way the demand curve has swept out these rectangles, if you want to think about it that way. And so we can look at this area under the demand, these bars under the demand curve, which amounts to the area under the demand curve. Right? If you want to think about what would happen if we went to the whole class, or the whole school, or the whole city, right? You would wind up with a whole bunch of very tall, very thin rectangles. In effect, you would get just the area under the demand curve, right? And for those of you who have taken calculus, and when you compute the area under a curve, that's how you do it, right? You look at very, very thin, dense rectangles, like that, bars, right? So, what we think about, what we want to do is we want to sort of attach some more technique and significance to this, and so we'll call this area under the demand curve up to this consumption point. You can think about that as a numerical measure of total satisfaction people are getting from consuming the product, right? So that's how I can actually measure total satisfaction that people are getting in the market. Now, what we're going to do is if we wanted to subtract out what people are paying, right? So you think about each of those pizza slices minus its price. I'll show you in a second. Well, then that's kind of like surplus, right? Consumer surplus. So is what we'll call it. So for example, let's take a price of, I'll take a price of 4, at which point we have 7 total slices being consumed, right? Once again, so now we're bringing in this market, or this idea that people behave and reveal their marginal benefits curves. And so we'll suppose that Jacob and his friend buy 7 slices of pizza at this price of 4. Well, that doesn't change the fact that one of them values that first slice at 10, right? So what we can do then is we can think about the surplus created by that first slice. It's 10 minus 4, right? the utility or the benefits, that you get out of it, minus the price you pay. 10 minus 4, so that would be this distance. The second slice, the same principle applies. It gives someone $9 of benefits, it costs 4, so that gives you 5, right? And we keep going along, and you can kind of see what happens. We get this triangle under demand but above the price as all of the surpluses from buying products in this market. Hopefully you see how that works, right? And so you think about this as the area under the demand curve up to the consumption point minus price. Consumer surplus. So, yeah, it's funny. I actually, I don't know how I got on the subject, but in my last class I was talking about my experiences as a graduate student. As it turned out, when I got through graduate school, I was very poor. And then I got a job and I suddenly had some money. And so I had to start, buying things for my apartment and all that stuff. And at one point I had to buy an iron, like where you iron clothes. So I went to Kmart and I was thinking, at this point you're sort of coming out of a fog as you finish graduate school and you kind of wandering around the world. You're like, whoa, what, who won the last, 3 Super Bowls? What was the biggest movie last year? Anyways, I went into Kmart and I had essentially no idea how much an iron would cost. And I was thinking, I don't know, I'll spend $40 on this thing. I have no idea what I'm getting into here. And I went in and lo and behold, an iron was about $8. And so I was thinking to myself, wow, I would have paid up to $40, yet I can get this product at $8. So I bought it, and in essence, I went out of there thinking the way we're thinking here, having earned $32 in consumer surplus, right? I would have paid $40, I paid $8. That was the going market price, right? And by this, through this means, I wound up earning some surplus for myself by buying something. Anyways, if you go to a market, right, the whole pizza market, I guess, it kind of works out like this, right? Everything we've said here. Here we have this market demand curve. I've labeled it here D equals MB, demand equals marginal benefits. And this is to kind of accentuate the fact for you that each of those points along the demand curve is someone's valuation for the product, right? The maximum they would have paid for a pizza in this case. So somebody out there would have paid $20 for a pizza, that very first pizza. Somebody here, this 5,000th pizza, somebody would have paid $15 for it, right? And as we go down and down and down, we finally get to this at the price of 10. That last pizza is worth to someone, they were willing to pay for it about $10, right? And so if we have a market price of 10, all of the pizzas along the demand curve above there actually give us the valuations. So, by the way, this could be, the same person buying multiple pizzas. It could be, across the population. But one of the reasons why we introduced this law of diminishing marginal utility, or the idea that marginal benefits are falling, but notice that if they weren't, none of this would make sense, right? So if marginal benefits for each additional slice weren't going down, we would never get this inverse relationship between price and quantity demanded, right? It wouldn't be the case that Jacob bought more pizza as the price went down, right? So in some ways, you can think about this any number of ways. You can think about it as, it seems like it's probably true because in practice demand seems to work this way. Or you can think about it as a way of theoretically rationalizing demand, right? This idea that you buy more at lower prices, right? Either way. But it's kind of a neat marriage between theory and practice. One other great thing about all this is that these are relatively easy entities to calculate, right? So with a little bit of geometry, at least with straight lines, right? We'll only use straight lines in this class. It's pretty easy to form exact numerical values for each of these things. So for example, the rectangle down here, we saw this last time, has an area that we can easily calculate. Well, it's 10,000, I guess, times 10. Right, 100,000. And what is that? What is this blue rectangle? Well, that's total expenditures, right? If we wanted to calculate out total benefits, right? Well, we could take this weird trapezoid, 0 to 20, it would go 0, 0, 0, 10, 10, 10, 0, 20, and that would give us the total benefits that people get in the market, right? But we could also just look at that triangle up there. That's the surplus, right? That's the utility or the benefits you get over the amount you spend for it. Or I should say people in general buying pizza in this market get, right? It all sort of flows from this diminishing marginal benefits of each additional unit, right? It's very kind of pretty elegant there. A lot of information here. So yeah, I could calculate that out. The rectangle is just base times height. That green triangle is base times height divided by 2, right? So it's 10 times 10 is 100 divided by 2 is 50, right? Would be the area of that green triangle. Very nice connection with theory there. Okay, so far so good? Okay, this is kind of and I tend to think of this as a big moment. It's a moment where you sort of figure out that there's more to supply and demand than you otherwise would think, and that you're actually able to say something about what we're getting in terms of value out of a market, right, which is kind of a crazy idea. Well, this can go a little faster because hopefully you appreciate the basic idea here, and we can think about supply in much the same way, right? So our rational supplier, that could be a firm. Here I have a pizza shop, Ray's Pizza. What happens is a rational producer should supply a product so long as the price is greater than its marginal cost. So what does that mean? Well, think about it this way. The marginal cost, here I have units in 100, but I'll just talk about them as 1, 2, 3, 4, where you can understand the hundreds. What this is telling us is how exactly this pizzeria works here. And it's saying that Ray can supply, per day, I guess, 100 pizzas. I don't know if that's a lot or a little. I don't know how many pizzas the typical pizzeria makes, but I don't know. So we're saying that the cost of producing that first 100 pizzas is about $2 a pizza, right? So maybe it's the case that it's pretty easy to cook pizzas. There's a lot of room in the oven, so you can do it pretty efficiently. If you only have 100, that's fine. The costs go up a little bit, maybe, if you have to produce an additional 100 pizzas, given you're producing that first 100 already. So as we go from 1 to 2, right, the costs of that next 2 is $4. So think carefully about what that is. It says our first unit costs $2 to produce. Given we're at that first unit, producing those first units at $2, producing another unit costs $4, right? And these costs are going up, and you might think about this as, the mechanics of production are changing, or you might even think about it as the principle of increasing costs. As we do more and more and more stuff to produce pizzas, it gets harder to do it. Maybe we have chefs in our kitchen who are used to, they make salads and sandwiches or something, right? And as we try to produce more and more pizzas, well, we find that we're shifting those people to pizza production, and they're just not as efficient at it, right? So we have to pay them we wind up paying them more per unit produced than we did for our first bunch of pizzas. But anyway, so what's happening is we imagine that these marginal costs are increasing as we produce more pizzas. Producing an additional pizza is more costly as we make more of them. Now, there are some reasons to sort of wonder if that's true. And we're going to do a deep dive into production and costs and all that stuff a little bit later. But for now, we'll suppose that this is how it works. But one of the interesting implications of this is that we can, just as we did before, we can derive a relationship between supply, right, the supply schedule, and marginal costs by thinking about things that way. So, for example, if we say, Ray, the price of pizza is $4, right? What should Ray do in response to this? Maybe it's like a little bit more than $4.05. Ray will say, well, let's see, I can produce 100 pizzas at $2, and then I can produce 100 more at $4, and I'm going to stop there. Because all those pizzas that I've just described, they cost less than the market price to produce, right? So if I make them and sell them, I'm making money, right? If I were to make an additional 100 pizzas, go from 2 to 3 at this point, well, then the marginal cost of that third bunch of pizzas goes up to 6, and now I'm losing money, right? Those pizzas cost more to produce. Those additional pizzas cost more to produce than the market price, so why would I do it? I'm spending 6 to produce something I'm only getting $4 for. So once again, marginal cost and price mimic each other here, or supply, I should say, mimic each other. And you might even do it this way, where you say, here's the supply, right? What Ray would supply, here's all the prices. And, of course, the marginal costs and the supply curve are exactly the same thing in this example. So what are the implications of this? Well, here's my kind of dumb-looking combined Google Sheets chart where I have the cost bar, right, and the supply curve there, kind of superimposed on one another. And so you can see the supply curve is down here, or I'm sorry, the supply curve below the supply curve, we get the marginal costs. So once again, this is something different than cumulative costs, right? If we wanted to think about what it's costing Ray to produce 3 units of pizza, well, we would say the first unit costs 2, the second unit costs 4, and the third unit costs 6. So the total costs of producing these pizzas would be 2 plus 4 plus 6, 12, right? We'd have to add up the additional costs of each unit. Now, there's actually other components of costs that make the comparison, we can't say these are all the costs of pizza. We'll get into these costs, but suffice it to say marginal costs are reflected on this graph. So if we brought in another place, this is just like Jacob and his friend, we now have Ray's and Joe's Pizza, and we thought about the consequences of all of this, and we sort of gave these two pizza operations prices and saw what they would do. Well, let's see, at a price of 6, we see that the two pizza shops supply 6 units. We can infer that that 6th unit cost right around 6 to produce. In the previous units, if we knew the supply curve, we could figure out that their costs would be in here as well, right? Now, you can imagine we don't just have to go with these 2 pizza shops on the block. We could go up to the neighborhood or the city, and the same principle would apply. Even though we don't know the exact identity of who's supplying the pizza, we still know what the costs of producing that particular unit of pizza were, the marginal costs, right? Now, the last thing I say here is that if we pick a market price and compare it to the supply curve, well, we then get an idea about what the surplus is that the pizza shop is earning, or some pizza shop is earning. So, for example, if I picked a price of 6, we don't change the fact that that first unit costs 1 to produce, right? So in essence, if you take imagine like drawing a bold line through 6 there. If we take that 6 unit and subtract the 1, we see that someone's getting $5 in effect in surplus from that first unit. Well, from the second unit, same thing. 6 minus 2 would be 4. Third unit, 3, so on and so forth, right? And hopefully you're beginning to sense what the geometry is underlying all of this. And maybe I'll take a leap here, and maybe partly in the interest of time. And we arrive at something like this, right? This breakdown of the geometry of the cost side or supply side of this, right? The area below the supply curve is the cost of producing pizza in general, right? Really what it is the cost of producing each unit of pizza. The marginal costs all added up, right? The additional costs. That's the pink area. The blue area is then the surplus, right? The price here in my example is 10. So if you take 10 and subtract the cost of producing the unit there, well, you get from this very first pizza here I have 5,000 pizzas. The very first one, the surplus is something like $8, right? Because it's easy to produce that first pizza, and it still gets $10, as does every unit sold in the market, right? Everything sells at the same price. So here we get a sense as to what costs are like, but also what producers are getting out of the market. Right? And that's why we call this producer surplus. It's what producers are getting over and above what they needed to produce a unit, right? At a minimum. Producer surplus. And of course, once again, you can very easily calculate these things using just simple triangles. I mean, this is it's a little bit more complicated to compute this thing down here, this cost. But you can use this trick where you can make any weird trapezoid into like a triangle and a rectangle. So, here, just make this. All right, now I'm starting to, I'm sure you can figure that out on your own here. Okay, well, what happens when we put it all together? Well, we actually get a picture as to what the total gains from exchange are in a market. Right? So you look at this and you can now say that green area up there is consumer surplus, and this blue area down here is producer surplus. Consumer surplus is what you value something at over what you pay for it. Producer surplus is what the smallest amount you would have needed to produce something, subtracted from what you get for it. So really I guess there's two lessons here. It's that in a market everybody's benefiting, producers and consumers. And the other interesting thing about this is you can see what these benefits are. Right? We get an exact quantitative measure of what these benefits are right from this diagram. So, and you can calculate it out, right? So I can even just, let's see, the area of the green triangle has a height of 10 and a base of 10. So the formula is base times height, 10 times 10 divided by 2 is 50, right? 100 divided by 2. So that area is 50,000. This area down here, it's a little bit more complicated. Well, let's see. We can do a trick where we turn our heads this way, and now the base is 10. I guess we can take this to be 2. 10 minus, well, it looks more like 1 maybe. I don't know. 2. 10 minus 2 is 8. 8 times 10 is 80. Divided by 2 is 40. So we'd have 40,000 and 50,000, $90,000 in benefits flowing through our market here. So that's kind of a neat thing, right? That you can actually, and this isn't something that's immediately obvious, that all this information sits there on this diagram. And so you can just kind of drink it in here. Look at we have the demand equal marginal benefit, supply equal marginal cost. We didn't even shade in this area underneath the supply curve, which is the cost to production of the pizza, right? But hopefully you'll get used to sort of looking at this diagram as the course goes on and seeing the surpluses, right? Okay, and you know what? Maybe a quick example. I have another example where we can calculate all this out, and then I'm going to tell you what the real big lesson is here, or I'm going to kind of tell you where this is going. So let me do this. Alrighty. So maybe we have a market that looks like this, where we have, let's see. I'll call this 20. Say it's not exactly anatomically correct, but here's something like that. Here's my demand curve. This is 0. Here's my supply curve. I apologize for my bad handwriting. I'm going to blame it on being left-handed. I just kind of can it's not that smudgy. But anyway. Okay, so consumer surplus would be the area below demand above the market price here, the equilibrium price, which is 6, right? So that is, let's see, this distance is 12? 14. What am I doing? 14. And this distance is 1,200. So we get 1,200 times 14 is... Anybody have a calculator? I forgot my phone. 1,200 times 14. I should be able to do that in my head, but yes. 16800. Okay. And then what we want to do is divide that by 2. This I can do in my head. 8400, and that is consumer surplus, right? That's the area there. What about this area down here? This is producer surplus, right? And this should be 6 times 1,200 divided by 2 which I think is, say that again? 3,600. 6 times 12 is 72 divided by, 3,600, and that is producer surplus, right? And so we could add these two together, and we would get the total gains to exchange in this market. So, and you might even picture it that way, right? So, yeah.
Sorry, I'm just wondering, what's that line that the consumer producer surpluses are above and below? Is there a name for that one?
This is the price, right? The equilibrium price, yeah. And usually, I mean, you think about it as a point, but you kind of draw, and that's a good question, you kind of draw it as a line. Why do you do that? Well, because then you can kind of think about this as, each unit you can say, all right, well this, imagine there's a little bar here like this. That's the consumer surplus from that unit, right? And it helps to just look at it as kind of this vertical distance. So you draw the whole line as the price. That's kind of a good clarification. Same with the supply here. So one thing I was going to say is you can almost conceptualize this as, if you just think about, do the thought experiment, where if you were to take all of the units produced in this market and you were to sort of line them up on one side of the, on one side of the room, you'd have the highest valuing consumer to the lowest valuing consumer. On the other side of the room, you'd have the cheapest producer to the most expensive one, up until this 10 here, right? And then you can sort of think about the difference between supply and demand at that point, right? Here's the lowest cost producer and the highest demanding consumer. And the surplus that we get when a pizza is cooked and transferred from one to the other is this distance to that distance. And as we go left to right, you can see that this scissors kind of narrows, right? Each pizza still produces more value than it costs, but it's getting closer and closer and closer until the very end, right? Where the last pizza produced is about equal to the benefits derived from that pizza, the costs, right? I should say the costs of producing it are about equal to the benefits derived. And it's interesting that we can measure all of these things, and I have a lot to say about that as the semester goes on. One other thing, as policymakers, given that this is a measure of societal welfare deriving from the market, that is to say it's a measure of what people are getting out of market participation, both sides, what we care about then is a little bit like what we were doing with the illicit drug market. Right? It's what we're going to care about is when we change policies or we put certain policies in place, how do they change these shapes and their sizes? Right? That'll give us a means by which we can judge whether a policy is doing good or doing harm, as the case may be. Right? And we're going to essentially be doing a lot of that. And of course, people, there'll be plenty of objections, but that's part of the point of doing it in this way, right? Is that we know what our model says and what it doesn't say. So I guess I will stop there and I will see you next time.